Hello, in this video I am going to explain experiment number 1 of Embedded Controller Lab. Display Hello World using internal UART, and at the end I will demonstrate the same experiment in lab. So as you all know, in our lab we are using LPC1768, and to conduct this experiment number 1 we have to configure this p2 dot, where I am pointing the cursor, p2.2, p0.2 and p0.3 pins of port NOT are configured as not as a general purpose input output, as a first option function, that is as an UART pins. So UART pins, we need a TXD and RXD NOT. So UART the UART NOT is used for our experiment. So here how to configure it. So as I told you, the ports are configured for ports by configuring the pin select. So as I am using a p0.2 and p0.3 of the port NOT pins for UART. So first, we look at here the pin function 2. The primary function of those pins p0.2 and p0.3 is general purpose by default, and if you want to select the first alternative function, we have to set it to 01. The same thing what we have did, 01 01. So the total value what we get for this nibble is 5, and rest all are set to 0. And so we have to write in our program this command instructions, so that the port p0.2 and p0.3, these two pins set as an UART second function. So look at here, so these two yellow what is marked here pins. Okay, so now, and at the same time, to conduct this lab we need a help of UART registers, and these are the UART registers. So what we have to configure, it is explained in our in a C file. So RBR contains the recently received data. THR contains the data to be transmitted. FCR, first in first out control register. LCR controls the UART frame format, that is if it is a number of bits are 8 bit, 16 bit, 32 bit, like that. And stop bit. DLL, least significant bit of the UART, a baud rate generator value. DLM, most significant bit of the UART baud rate generator value. So now I will explain the program. So this as you know, we have to include LPC17xx.h header file, where these all registers and the keywords which are related to LPC1768 Cortex M3 ARM controller related registers and keywords all are defined, blocks, values, ports all are defined. Then STD, standard utilities, also we have to include. These are the bits we have defined for our use here, and then we set the pin select. As I told you, first we set the pin select to enable P0.2 and P0.3 for TXD and RXD for UART functions. Next, then the two registers what I mentioned in the previous slide, that FCR and LCR, they are to configure. The FCR are configured for enable a first in first out and reset a buffer, and then LCR configured for 8-bit data, 1-bit and no parity. That's a bit set word length. It is here bit set word length we have set as an 00 first. So that bit set length, everything is configured, and then we have to set the UART for a different baud rates. So this is the things about we have with system core clock divided by 4, and it will help us to set the with a different baud rate. And we have to configure the DLL and DLM, the two registers which help us to transfer the data with different data bit streams. Next, this is the what transmit the character function is written separately, and this is the what function written for UART initial. There are two functions, UART initial and UART bit transmitter character. This is the main function. So this is the what we have defined here is a variable called as a char, where we define so we in a double inverted comma we have written a hello world. This is to be displayed, and we call the UART initial, and then we set that a 9600 baud rate for that this function is written, which is in the blue, which is written for to set the baud rate for data exchange. And then we call this UART for that character to be transmitted bit by bit. We transmit the character. So if it is a 8 bits, so I is 8, so one after the other 8 bits are transmitted. Okay. So in this slide you can see watch the experiment conducted in lab.
In this video, I am going to demonstrate experiment number 1, display hello world message using internal UART of LPC1768. For that, we have created one folder called the test, and in that folder we created a UART folder. And then we start open the file software IDE, Integrated Development Environment, and we create a new project. Once you create a new project, that new project name UART, and then we have to select a target board. On the target board, we have LPC1768 NXP-IC. The same we have to select here, the LPC1768 NXP-IC. Once you select, we have to create a C code. The code which one we have to dump it to the target board. This is the code what is written in editor window. After that, we have to save this C file with we save this C file as an UR.c. Then at the same time we have to include std utilities.h header file in the folder in which this project is stored. Look at here, we have saved that file in this that helps us to run this code. This is a support file what is need to be added. Now we have to save and then build it, the program. Before building we have to add the C file URT to this, and at the same time system file to this. So look at here, they got added C dot URT dot C, and the system file is also added. Then we have to save and build. Once you save build, now we'll see error-free program, and then we have to create a hex file. So to create a hex file, we have to go for target options, where we have to create a hex file. The hex file is get created with the same C file ur.c. If you want, you can change it also. Now we have to open the Flash Magic to dump the code to Kit. Once you open the Flash Magic, you have to set the settings as displayed on screen, and we have to select the hex file which is created. And before dumping to the kit has to be configured or set for program mode. We have to set the switch button in program mode, and we have to press the reset button. Once you press, you have to press here start button to start the dumping. So you can see there it's verifying and dumping the code. Finished. So now after finish, so we have to open the hyper terminal where you can see the result. Tool on the Flash Magic only, tool, then hyper terminal, COM3 you have to set, and the baud rate 9600. The whatever the settings is as on display. Now we have to press reset here to display the message. I hope you can see here display. So we will press the button, you can see the display. Every time when you press the button, the hello message is displayed on hyper terminal. Thank you.
Thank you for watching video. Please press the like button and subscribe. Thank you.